In this presentation, I would like to provide an overview of ToxBank and its role in supporting the acceleration of the flow of knowledge and the sharing of knowledge on the different research activities on the SURET program, whose goal is development of alternative testing methods in predictive toxicology. In our working world today, we often are working away on our own challenging problems, on our own islands, and the typical outcome of that is a lot of our knowledge is shared only locally. However, as our challenges are more complex, more interdisciplinary, and increasingly involve larger and more complex data sets that we need to integrate into a common framework for the development of safety assessment methods. The development of resources that are interoperable, that can integrate evidence together in a reliable way, becomes a really critical success factor in the goals of such a program. Knowledge can flow or not flow in many different ways. We have meetings in which we share knowledge, tacit knowledge that is in our head, that needs to be captured. We have knowledge that's generated in the research laboratory. We need to combine knowledge from different kinds of sources through common ontologies. We need to convert knowledge into products we can develop and bring to the market. And in all these kinds of activities, there are flows of knowledge between different systems and people that we need to accelerate so that we can have faster progress, so we can move closer to industry application and regulatory acceptance, so we can have innovation success. The Nonaka and Takuchi framework provides a knowledge-oriented framework for the conversion of tacit and explicit knowledge, tacit knowledge being in our heads, explicit knowledge being the knowledge that we create that, that can be explicit data set in the laboratory, for example. And within ToxBank, what we try and look at in terms of our support is that we have a balance between these conversions of knowledge, between tacit and explicit, that we apply experimental designs in the laboratory to create data sets, that these data sets of different kinds can be combined with each other, that we can then learn from their application to an assessment situation, and that we can improve the knowledge sharing through our meetings and have a cycle of innovation and acceptance. So this aspect of knowledge sharing and how our systems are supporting it, regardless of whether it's happening in social situations or in situations where we're doing our work in the laboratory, in the office, we have to capture and share in a more effective way. From an architecture point of view, we base our system on OpenTox standards. These are open standards that can be applied to any particular software component. For example, that component might describe a data set or a prediction model or the validation of that model. So it could be used in a validated sense for an alternative in safety assessment. So these standards were developed in the OpenTox project, and within ToxBank, as an infrastructure development project, we've been extending these standards so that they can be used to support all activities within the program. And this allows us to build a variety of different applications based upon this framework, this ecosystem approach, where we can put different components together for different use cases. So the use case might be developing the knowledge for an adverse outcome pathway, or it could be applying an integration of a weight of evidence to a read-across safety assessment situation. So there are different applications we need for different contexts, but by using this component-based approach and these OpenTox open standards, we can build a variety of different applications. Now within SURET, there are a number of different building blocks, different research projects we have to support, involving over 70 different research groups from both private and public sectors. It can be small companies, universities, research institutes, and end users in larger companies. So we have to support this knowledge flow and knowledge sharing between a variety of different kinds of organizations, different kinds of research projects, and bring it all together. ScreenTox is a project in which stem cells are being developed for testing purposes. HemiBio is developing a microfluidic bioreactor so we can have an alternative human-based liver system in which we can test the safety of chemicals. Detective is combining a variety of different kinds of biological evidence, for example, omics experiments, functional data, so that we can have an integration of such in vitro evidence to discover and develop biomarkers for the prediction of toxicity. Cosmos is a project in which a variety of different computational techniques are being applied so that we can use in silico modeling for calculation and estimations of side effects of molecules. Whereas NoTox takes a systems biological approach, attempting to think in a systems-based way how we could integrate different sources of evidence on cellular systems to predict adverse effects of molecules. ToxBank, in its role as an infrastructure, must support all these different kinds of activities that generate different kinds of data sets on these projects and combine it into one data warehouse where all protocols and data sets are collected in a harmonized way. We also have developed the reference compounds for the program, which provides a chemical-based basis to the integration of our evidence, and repositories supporting the gathering of information on these chemicals and also, importantly, on the biological materials as well. So in terms of the end goal of where we're moving towards with ToxBank is the support of the user, the scientist in the laboratory, who must design experiments. For this, they need SOPs, protocols for their experiments. They need reliable sources of reference compounds, biological materials, and also what is the background knowledge in terms of existing data and models for their work. And that ToxBank can supply this background knowledge in the experimental design, and then as the experiments are being conducted, that protocols and new data are being integrated in a reliable way into ToxBank to improve and the development of predictive models.